Alright, I'm on page 517 on 12.5. Let's do a lot of the examples here. Let's start with number 1. Got the book pulled up here as well. It says, given triangle congruent statements, complete the following statements for congruence of corresponding parts. So I have a congruent statement here. Triangle TXC is congruent to triangle CDW. Therefore, segment TC, so I've got T and C right here, would be congruent to, it should be segment CW. Again, line up your terms. Let's try number 3, line up your points. If triangle ABC is congruent to triangle QPB, segment BC, the last two right here, would be congruent to segment PB. And number 5, angle T is congruent to, well, angle T is right here, so therefore it would be congruent to angle C. Make sure you have the segment symbols and the angle symbols. Let's move down to number 7. Given triangle similarity statements now, let's finish the statement. So these triangles are now similar to one another. Therefore, angle J, what do we know about the angles for similar triangles? Well, the angles, corresponding angles for similar triangles are also congruent. So therefore, angle J and angle N are congruent to one another. Number 9, if those two triangles are congruent, then angle A would be congruent to angle C. If these triangles are similar, then NP, here's NP over YZ is equal to or proportionate to what over XY? Well, XY is right here, therefore it has to be MN over XY would finish that statement and make it equal. Let's go down here to number 13. It says find the corresponding parts for the following. Let's see here. So number 13, we're looking at the corresponding parts for these first two triangles here because we're dealing with AB. So therefore, AB is going to correspond with FE, not EF. Notice the triangles, they're almost mirror pictures of one another, right? What kind of triangles would ABC and FED be? They would be congruent because it's the same shape and the sides, everything's the same size as well too. We'll talk about these triangles on the other side here in just a second. So therefore, number 13, segment AB and segment FE, those would be the corresponding parts there for these two congruent triangles. What about number 15? Now we're talking about these triangles over here. These triangles, RST and VUW, are similar triangles. Same shape, but they do not have the same length sides. But for similar triangles, the angles are still corresponding and congruent. So angle R and angle V, those are your corresponding parts for number 15. And then number 17, you've got segment TR, starting up here, TR. Which side would it correspond with? Segment WV. So that's number 17, segment WV. Number 19, write the statements showing the relationships of the pair of triangles above. All right, well, you tell me for number 19, which ones are similar? Well, these two triangles over here are the similars, so therefore we need to write a statement, a similarity statement. So we've got angle RST is similar to triangle. Okay, R and V correspond, S and U correspond, and W and T correspond. So make sure you have the correct order there. Number 21. Let me move this over just a little bit. All right, number 21, we are looking to use proportions and we're looking to find the missing length. So number 21, we've got two missing lengths. We've got X and we've got Y. Now, what kind of triangles are these? These are similar triangles. So if they're similar triangles, then their sides are proportionate. So therefore, AB over DE is equivalent to or proportionate to side BC, which is actually one of the missing lengths that we need to find, BC over EF. So let's plug in our values. What is AB? AB is 15. DE is 10. BC, we don't know. That's actually the length X, which we're looking for. And then EF is length 16. 15 times 16, we did that earlier. Cross multiply to solve is equal to 10x. Therefore, what is x equal to? What's 240 divided by 10? X is equivalent to 24. So if you want to write in 24 right here for the length BC, that is one of your missing values. Now we're looking for y. So let's see here. We're looking for y, so we can start with the segment where y would be found, which is DF over AC. We started with our little triangle and then went to our big triangle. So for our next proportion, we've got to start with our little triangle. It doesn't matter which one you use. You can use 16 over, this is 24 now, or you can use 10 over 15. Let's use the smaller one, ED over BA. And let's plug in our values. These are proportionate, so they're equal to one another. DF is y, AC is 30, is equal to ED is 10, and BA is 15. Let's cross multiply. That's 15. Y is equal to 30 times 10 is 300. Divide both sides by 15, so therefore y is equivalent to 20. Here are my two missing values. Make sure you find all the missing values in each of these problems here. Let's do one more of these, number 25. And yes, you may use your calculator for these. Let me pull up a new file here. Right. Here we go. Exit out of this one. So number 25, we're looking for x and y again. So let's find x first. We've got AC over DF. That is equal to, we're going to have to use BC over EF because we can't use AB over DE because y is a missing value. AC is x, DF is 20, BC is 45, and EF is 18. So let's cross multiply. I've got 18x is equal to 45 times 20. My calculator out. That is 900. Divide both sides by 18. X is equal to what? 900 divided by 18. That is 50. Now let's find y. So y is segment ED, and that is proportionate to the other side, other triangle side of BA. And then we've got, let's use DF and AC. All right, ED is my missing value, BA is 30, DF is 20, and AC we found to be 50. So cross multiply is equal to 600. Divide both sides by 50, and what do you get for y? Y is equal to 12, and these are my values for x and y. All right, let's look at the back and do a couple more problems, and then you'll have some of the evens to do for work. So here we go. Number 27. We're still looking for our missing values, but notice what they've done. They have flipped these triangles around. So now we've got to be very careful. Here's what I highly recommend. I highly recommend that you write your similarity statement up here, first and foremost. So let's take a look at this triangle right here. I like to start with the smaller angles so that I can line them up. So triangle CBA A is similar to triangle. All right, now let's look at the little ones. So angle C and angle F, they have to be corresponding. And then angle B and angle E have to correspond. So E is going to be the next letter. And then lastly, A and D correspond. So match them up, C and F, B and E, A and D. They all have to have this exact corresponding parts according to your diagram right there. Now, here we go. Let's find our missing measurements. We've got FD over, so F and D is proportionate to CA. You can look at the diagram or you can look at your similarity statement up here. Is similar to, let's see here, what are two that we started with my smaller diagram, so I have to start with my smaller numbers. We know that, let's see here, FE and, we can't use FE and CB. What's my other one then? We've got DE on my smaller one. DE and AB. So DE and AB. All right, let's plug in our values now. FD is X. CA, that is 24, is equal to, let's see, segment DE is 3 and AB is 12. The key here is this part right here, is making sure that you're going to get your corresponding parts accurate. The rest is easy. Here we go, cross multiply. 12x is equal to 24 times 3 is 72, therefore x is equal to 6. Now let's find our value for y. Y is going to be segment BC over, let's see, BC and EF are corresponding sides, and then we can use any other corresponding sides. But remember, we started with the big triangle, so we have to start with the big triangle. Let's do CA. And what corresponds with CA? FD. Here we go. BC, that is Y. EF is 8. CA is 24. And FD is X, which we found to be 6. Cross multiply. 6y is equal to 4 times 8 is 32. 16, 192. And y is equal to 192 divided by 6, which is what? 32. X is 6, and y is 32. Take a look at number 29. This one may look like it's super tricky, but I'll show you. Let me erase this real quick. Let's see if can I get this any bigger? There we go. Maybe easier just to get a new screen, but I'll do that next time. Okay, take a look at number 29 though. This isn't going to be for your homework, but you may see something like this at some point. They don't even give you 2 pictures, but what can you do? You can actually break these 2 up into 2 triangles, correct? You've got a bigger triangle, and then you've got a smaller triangle inside. All right, so look at it. Here we go. This side right here is this side right here. This is the big long side, and that's 20. This side right here is y. What do you think this side is? Well, it's 16. Let's look at the little triangle. The little triangle is this triangle inside right here. So this piece would be 9. This segment right here, down here, would be 12. And this side would be x. Now you've got 2 similar triangles that you can do proportions to. So y and 9, 16 and 12, 20 and x, those would be your proportionate sides. And you could use proportions to solve for the missing variables. Number 31. Are the following pairs of triangles similar? Right? Yes or no? What do you think about number 31? doesn't give us points, but we've got a 90-degree angle and a 90-degree angle. That's correct. How many degrees are in a triangle? 180 degrees, right? So, let's see here. This angle right here would be proportionate with this angle. Therefore, this angle and this angle would have to be proportionate to one another. So this angle right here would have to be 11 degrees as well, too. This angle would have to be 79 degrees. Would that make sense? Is 11 plus 79 plus 90 equal to 180 degrees? Yes, it is. So are these two triangles similar to one another? Number 31, yes, they are similar to one another because the angles correspond and they are congruent. And then number 33, here we go. Last one. Two regular hexagons have sides of 3 and 5.2 respectively. So regular hexagons, that means that they have 6 sides, first of all. They are regular, so all the sides are the same exact length. So two regular hexagons, 3 and 5.2. Let's see here. Are they similar? Well, if they are similar, then this triangle this hexagon over here, that one is going to be bigger. It's going to be the same shape, but it's going to be bigger. I know these aren't the best, but bear with me. Here we go. If this one has side 3 and this one has side 5.2, how would we figure that out? Are all regular hexagons, are they going to have all the same interior angles? Are all of their corresponding angles congruent? Yes, they are. So yes, they are similar. That is the answer. But why? Because all regular hexagons, they're all going to have interior angles that have the same measurement. Therefore, they're similar. Are these two hexagons, are they congruent though? No, they're not congruent, but they are similar. All right, that's all for today. You've got the evens 2 through 34.